Suppose that f is a continuously differentiable function. Assume that limit x tends to infinity, f of x is 0. Which of the following statements are necessarily true? So f of x is tending to 0. We are given that this f of x is tending to 0 as x tends to infinity. So we have to check these 4 options. So now, like, if we consider the first option, so f dash of x doesn't necessarily tend to 0 as f of x tends to 0, because if we consider the counter example, let's say if we consider like sin x by x, so sin x by x like tends to 0 as x tends to infinity. But if we take like f dash of x, which is minus sin x by x square plus cos x by x, so this is an oscillatory, it has an oscillatory nature and it does not converge. So therefore first option is not correct. If we consider the second option, so limit lim sup of x tends to infinity, f dash of x is 0. So again, like, we can use the same counter example. So if we take f dash of x, this is oscillating and have positive lim sup. So therefore the second option is also incorrect. The third option says limit x tends to infinity, infimum of f dash of x is 0. This is also false because of the same reason, because Liminf could also be negative. So therefore the correct option would be option D, because this can be true, because if we consider by mean value theorem, so if we use mean value theorem by MVT, so for large xn which tends to infinity, if we consider the intervals xn and xn plus 1, so f of xn minus f of xn plus 1 is equals to f dash of this xi of n for some this xi of n belonging to xn comma xn plus 1. So that means this f of x tends to 0, mod of f of xn minus f of xn plus 1, this also tends to 0. So that means f dash of this xi n tends to 0. That means that Liminf of this mod of this f of x will be 0. Therefore option D is the correct answer.